Thank you everyone for joining. The RAG session is the word of the day. My name is Ina Kolova. I'm part of our product team at Databricks, and today we're going to go through the introduction of RAG. So I'm going to start with the benefits and the downsides of working with LLMs. We're going to lay the foundations. We're going to talk about how to leverage your own data, the real purpose of RAG. We're going to define what RAG is. I'm going to go with you through the architecture. We're going to do a demo on Databricks for you to see how it works. And then we're going to talk about compound AI systems. All right, so first I wanted to speak to you a little bit about how LLMs work. So these are large models which were trained on a corpus of data set. It's a corpus of data which could be open data sets, tweets, it could be basically the whole of the internet, research papers, etc. And what's really cool about LLMs is that unlike your typical search systems, they would give you a direct answer. You don't need to aggregate the data. And that direct answer sounds a lot like a human. It has the correct text structure. It produces extremely very easy to comprehend content. Now, the downside of it is that those models are only aware of the data they were trained on. So they would only have facts about things that were within the tweets they were trained on, research papers, etc. So what happens is that while those LLMs may sound extremely believable and sound like a human, they may not really give you the factual information. This is an example that a colleague of mine tried with an LLM. We asked what comes after tries, and the LLM started giving us the sequence once, twice, thrice, and then it started making up other words. For those of you who were not aware, these don't exist. So we said, hey, are you sure? The Oxford Dictionary says you're wrong. It said, yes, you're correct. I'm sorry, I apologize. That sequence doesn't really exist. But the point here is LLMs can lie to you very, very confidently. I asked it, so for the tennis fans here, Roland Garros, it's the French Open, it's a tennis tournament. I asked it how many years ago was Roland Garros founded. And we asked 4 different LLMs, getting 4 different answers. That's pretty weird, right? So all of those answers were basically dependent on the corpus of data the LLMs were trained on and the associated freshness. One of them even thought that I was asking it about the Roland Garros stadium, not the tournament, because it didn't have the context. So you can see how unreliable that could be. And if we're thinking about a real business use cases we want to bring to production, we want to make sure that quality is consistent. So what are the challenges? Those LLMs may not always give you the correct answer. They may not be up to date. Sometimes they don't give you a source or citation, and they're not based on your data. To give you an example, if we ask an LLM, what does DBRX stand for? You may get something like, well, I'm sorry, I haven't heard. That could be an LLM that hasn't really seen latest releases of open source models and doesn't know that DBRX is the open source model from Databricks. It doesn't know about that specific data set. And while we know these are major challenges, we know that LLMs can unlock a lot of business value if grounded in the right context, if grounded in the enterprise data. So how do we overcome those challenges? To give you a few use cases, we're working with many customers at the moment, but one of them would be building a Q&A bot on your internal data sets, being able to ask questions on your HR policies, product manuals. Another one would be giving a support bot experiences, giving personalized content to the customers based on their, let's say, purchase history. Another one would be content generation. Think about being able to generate marketing assets on the basis of previously successful ones. Summarization, only useful if grounded in your enterprise data. Being able to talk to your data, being able to ask questions on your reports, being able to ask questions on your dashboards, incredibly interesting use case, and personalized experiences. All of those unlocked with the power of LLMs if we manage to overcome the challenges I mentioned before. So if we want to ground this particular interaction, we somehow need to introduce the data sources that actually contain the information that the LLM needs in order to give a correct answer. And for enterprises, what we see is that those are usually in SharePoint articles, they're in your Confluences, they're on your cloud storage, they're in your Google Drive environments. So how do we securely and reliably provide that context to the LLM so that we can ground it in data that we believe is trustworthy? So you have basically two ways of going about this. You can take an LLM off the shelf, you can take an open source model, and you can train it further. You can introduce it to those documents and basically customize it. So this is what we call fine-tuning or continuous pre-training. That gives you a customized model that now has context on that data that you need to answer questions on. And then we can take the user question and we can hit the new customized model with it and we can get the answers we are after. Or alternatively, we can get the user question and append the supporting context to it. So now we have this new prompt which contains the answer and contains the question, and we can query the LLM with it. You can do both of those, and we recommend you do both of those, but essentially if you were to oversimplify what you can do, you either need to make the model smarter about your data, or you need to give it the answer because it hasn't seen it. So the latter would look something like this. You would give the context to the LLM and you would say, well, given the context over here, can you please answer this question? This is how the prompt would look like. So let's talk about this supporting context. What are our requirements for it? So the first thing, it needs to be real time. We don't know about the user question before it's asked, and therefore we need to actually retrieve the supporting data in real time. It needs to be relevant, so it needs to contain the context that is needed to answer the question, and it needs to come from our enterprise sources. So the content needs to be coming from SharePoint, from Confluence, from Google Drive, as we said before. So how can we do that? How can we provide this supporting context as part of our prompt so that we can provide it to the LLM? The way to do this, you would take your enterprise data. This could be PDFs, Word documents, PowerPoint presentations, etc. You would extract the text, you would extract the content, and then what you're going to do is you're going to group it into chunks. And you can think about chunks like paragraphs or a couple of sentences together. Those are your chunks. Then you're going to convert those chunks of text into their vector representation. A vector representation basically positions your chunk into a multidimensional vector space. So chunks that are closer together in that vector space will be semantically similar. So chunks that are talking about wind turbines, for example, will be closer together and further away from chunks that are talking about LLMs, right? Then you're going to take the user question and compute it into its vector representation. You're going to put it into the same format as where the relevant data is, and that allows you to perform similarity search, right? Similarity search is going to be able to give me the, let's say, top 3, top 5 chunks where the relevant context is. And that now is my supporting data. This is the backbone, this is the system that is going to allow me in real time to get that supporting data which is relevant, and it's coming from my enterprise data. If we put all of this together, we would take our enterprise data, we would get the text chunks out of it, we're going to use an embeddings model to put them into their vector embedding form, and then we're going to hydrate an index that we can query later for the top and most relevant chunks. Then when the user question comes in, we're going to convert it to its vector embedding through the same embeddings model. And we're going to query the vector index. Hey, give me the top 5 pieces of information where the answer might be contained. We're going to structure a prompt. We're going to combine the question, and we're going to combine the supporting context, and we're going to ask the LLM for the answer to this, and then we will return that answer to the user. This is the architecture of what we call Retrieval Augmented Generation. So just to repeat, it's a generative AI technique. It allows you to dynamically retrieve fresh, relevant information and provide it to the LLM at real time, at the time your user is asking that question. So what are the advantages? Well, now we can use our enterprise data sources. We can answer questions we have not been able to answer before because the LLM doesn't have that context. The LLMs are way less likely to hallucinate, so the quality of our answers grows immensely. There's no need for model modification. I am just using the model as it is, and I'm providing the context in the prompt. And as long as my knowledge base stays up to date, I can actually, without changing anything in the architecture, provide fresh answers as my data changes over time. No code changes are needed. I'm just querying that knowledge base. So we work with a lot of customers in Databricks. We have plenty of folks that are going to speak to you about having their use cases in production. Lippert, for example, they wanted to onboard their customer support agents more quickly. So they took their product manuals, YouTube videos, support cases, they combined them into a knowledge base and built a RAG solution to help answer customer queries and enhance efficiencies. So back to the architecture. How do these map out to services? Because I want to show you a demo. How do these map out to services that can make this possible? So what you end up having is your files and tables in Unity Catalog. This is our unified solution for data governance. Then your text chunks, your text data, would be in a Delta table. And then we can leverage Mosaic AI vector search for applying the embeddings model, getting those vector representations of our chunks, hydrating the vector search index, and querying it in real time. All of this managed by the service. So I want to show you how this works in the real world. All right, so for this demo, I've chosen a dataset with hundreds of LLM papers. And those, to show you a few examples, may look something like this. They may have text, they may have images, equation, papers. This one is on PRP. This one is on Lamantino. These are customized Llama 2 models for understanding and generation of Italian text. So we're taking this as our example dataset. So I want to check if I don't do RAG, will the LLM know about this? I'm just going to ask. Let's log back in. All right, we're secure. All right, so I'm going to ask what is Lamantino to see if the DBRX model knows about this. Well, it doesn't. Lamantino is not widely recognized term. So in this demo, we're going to try to fix this. I want to give it that context. I want it to answer this question. All right, so the first thing I need to do is I need to introduce those LLM papers into my data catalog. So I'm going to put them in a UC volume. So I'm going to click create and I'm going to create a volume. I can call it something around raw text and create that volume. Now, I want to upload my files. I have those PDFs on local, so I'm going to click upload to this volume. I'm going to browse through the files, choose one of them just to show you how it works, open and upload this file. So now I have my PDF file of one of my research papers in a UC volume in UC. So we've already done that for you. We've already uploaded all the hundreds of LLM papers, and I am ready to start processing that data, putting it into chunks and hydrating my vector search index. So I have my files in a UC volume. I'm ready to start chunking them. Now, we've prepared a generative AI cookbook for you with a lot of sample code for parsing, HTMLs, PDFs, etc. I'm going to give you a QR code for this later on, and you can start with it, but I'm taking some code from there. So I have a notebook over here, which is going to parse my PDFs. It's going to extract the text and put it in a table for me. So I can have the number of pages and I have the content. We can expand some of this. And here we have one of our papers and all the content out. The next step I want to do is chunk it. I have the text out. Now I want to split it into chunks. I'm going to use another function for this. This is all coming from the cookbook, so you can get started with it. And I'm applying it, and I get my chunk text over here associated with a chunk ID. All right, so where do all of these tables live? So all of these tables end up living in my Unity catalog schema. You can see I have my, my parsed document files. I have my chunked ones as well. Let's open the chunk one and see some sample data. All right, so I have which document does it come from? I have the chunk text, I have the chunk ID. It would be interesting to actually see the lineage here. I'm going to see the lineage graph. All right, so I have this gold chunk text data. It's coming from my parsed documents, and these are coming from the raw files table coming from my volume. All right, so this is my workflow. So I have chunked those files. I am ready to now put them into a vector search index. I'm going to go to my chunked files table, this one, and all I need to do in order to put this behind a vector search index is click create on the side. I want to create a vector search index through the UI. I can name this index. I need a primary key. This is my chunk ID. I need an endpoint. I need my embeddings source column, so that will be my chunk text, and I need an embeddings model. Recently we released a new GTE model, so I'm going to use that. And all I need to do is click create, and that is going to start syncing my Delta table behind a vector search index, and I can start querying that index with the REST API and getting similar chunks out of it. So we've already done that for you over here. Let me refresh this guy. So we've already done that, and this now allows me to start querying the vector search index. All right, so basically what we've seen from the architecture, we've managed to take all the PDF content, we put it into a UC volume, we extracted the content, that landed into a Delta table, and we sync that Delta table behind a vector search index, which is ready to be queried. All right, so for the second part of our demo, we are going to deploy that behind model serving. Why do we want to deploy that behind model serving? Because we want our users to be able in real time to go through this process. We want to accept their questions, we want to query the vector search index, construct the prompt, generate the answer with the LLM, and return that to the user. So for this, we're going to use model serving, and we're going to use agent evaluation. All right, so for this part of the demo, I have an example LangChain chain over here. This is also coming from the codebook. This LangChain chain is accepting the user question. It is querying vector search for the most relevant chunks. Then it's constructing the prompt. It's using a prompt template, and then it's hitting an LLM in order to generate the answer. So this is an example LangChain chain. You can bring your own chain. You don't necessarily need to use LangChain either if you're using another framework for orchestrating this process. So I have this chain, and this is what I want to run when my user asks a question. For me to allow my user to have this real-time experience, I need to put this behind an endpoint. I need this to be in real time. So what I'm going to do is I'm going to use MLflow, LangChain type of models, and I'm going to log that chain as a model. All I'm doing here is saying, here's where my chain lives. These are the configurations that I have for it. Log it as a model. Now this allows me to later on deploy that and be able to use it in real time. So I'm logging the model, and I can test the model locally into the notebook first. I can pass it the correct schema with a question such as, what is an LLM, and get an answer. So what you're seeing over here is actually the full trace of what happened when I asked that question. Because I logged that as an MLflow LangChain type of a model, I can actually see the input and output of each of the steps, and I can use that for debugging. I can also see the associated latency, so later on, if I am interested into optimizing how quickly that runs, I can actually identify which step takes me the longest, and I can go from there. So I've logged this now, I've logged this chain as a model within MLflow. Where do models go? Well, in Unity Catalog, we govern and manage and store models alongside data assets. So back in my schema, yes, I have those tables with the chunk data. I can also see my models on the side. So I have this model over here, which we registered, and it contains my LangChain chain. All right, you can see different versions of the model, and if I am ready to start serving that chain, I can basically click on Serve Model. I can give it a name, I can configure it with the compute requirements, and I can serve that behind a Mosaic AI model serving endpoint. All right, so this usually takes a few minutes to spin up, so let me refresh here. So we have an endpoint that is launched already, and this endpoint runs the LangChain that I showed you earlier. You can just serve it from within the catalog. All right, so I have my LangChain served. It is calling vector search index. It's doing the architecture that we saw earlier. So now I wonder if it's going to know about the content that was within the papers that I fed to it, right? Does it work? So a lot of customers wanted to try their RAG applications very quickly, and we know a lot of folks are building UI, building evaluation UI. What we wanted to do is pre-build that for you. And this is how I'm going to test my LLM now. I'm going to ask it, let me just copy the Lamantino. I'm going to ask it what that is. What is Lamantino, and see if it knows. All right, so Lamantino is a family of Italian models developed by a team, etc. So this is what my research paper was about. So what happened over here is that we went on and took data from our sources. Here I can see them. All right, so we tested the application over here, got an answer on our Lamantino paper, and this basically now gives us an opportunity. This is the review app, by the way. You're going to hear about this later in different sessions, but this allows us to also provide human feedback to the application, see what chunks were returned, and interact and test different versions of the bot. All right, so I'm going to move on to, all right. So we tested what establishing RAG is. How do we go to real prediction? How do we decide that this system now performs in satisfactory manner that we can consider it for prediction? Well, RAG, if you think of it, isn't the same as evaluating a model. You're evaluating a system. You're evaluating a quality of how good your retriever is, how good the parsing of the documents was. You can change so many knobs in the system. You can change your embeddings model. You can change the generative AI model. There's so many things that affect the final quality of your RAG application. So instead of thinking about RAG as an entity, you think about it as a system. And that's what we call compound systems. And an example for compound system would be a multi-step chain, or a system that includes a fine-tuned model, or RAG, or agents and toolings. These are all systems. So evaluating, iterating, and versioning those systems when putting them to prediction is very, very important. So we're seeing this shift, and you're going to hear about this a lot on the keynote, but we're seeing this shift from evaluating and improving models to evaluating and improving systems. And RAG is one of those systems. So what you want to consider when going through that process is, well, one of my challenges, I need to be able to measure that system. I need to be able to evaluate it if I can improve it. This is how the scientific method works. Unless I'm able to measure it, I cannot improve it. And for me to measure it, I need to have sufficient amount of feedback. What is that feedback? That could be evaluation metrics, such as recall and accuracy, but it also could be human feedback. It could be LLM as a judge. There's so many sources of feedback. So collecting enough of that data to allow us to compute those metrics is very important. Using those to improve the quality, reduce hallucinations, and enforcing guardrails. These are some of the challenges for systems that we hear from customers. And these are the challenges that establishing RAG also introduces. So you want to end up doing is iteratively collecting feedback on how your system performs from different sources, human feedback, LLM as a judge, using that feedback to calculate, evaluate the performance of that system, and then systematically making changes to it. Systematically and in a versioned manner, making changes to your RAG, and then improving. You can think about it as the inner dev loop of your RAG application. So you want to keep on doing this. All right, so in summary, what we covered is what is RAG? RAG is a proven method for introducing enterprise data sources to your GenAI application, and it leads to better quality responses, and it leads to more factual responses with less hallucination. We went through what the RAG architecture consists of. It has an offline process for you to introduce the data sources that might be within your enterprise knowledge bases to a vector search index, and then in real time querying that vector search index to get the context and giving that to the LLM. And RAG is a compound AI system, and it should be treated as one when you're going to production. You should think about the way you're going to evaluate that system, the way you're going to iteratively make changes to it, and improve. So what I'm going to leave you with today is our RAG cookbook that I encourage you to take a look at. Also the RAG Quick Start, which has notebooks for establishing RAG, and would invite you to also go to some of our following RAG sessions to dive deeper on the points that I mentioned around consistent evaluation and versioning the system. One is happening very soon. The deep dive into building production quality GenAI applications will be a great session, and many more coming. Thank you very much for coming.